Yeah, g'day, and welcome back to my channel. Now last week I put new seals in this automatic tool changer, which is pneumatically controlled, but I got the wrong size seals, so it didn't work. So this week I'm going to try putting the right size seals in it, putting it all back together, wiring it up, and getting it going. Last week I asked you guys how you went about sizing O-rings, and pretty much all of you use one of the major catalogs, especially Parker's catalog seems very popular. But my mate Luke put me onto this online calculator from Eric's, and that was quite handy, so I used that. Once you've calculated the values, you can hit show me what you've got on the catalogue, and it shows you what O-rings it would choose for you. So after using that online calculator, I came up with either 10.35s or 10.3s, so I've decided just to buy both of them. Let's give it a look and see how they actually fit. Because these valves need to be pneumatically positioned, I don't want too much drag on them. Okay, that's definitely gripping it quite nicely. I'm guessing that will actually seal. Let's plop it in and have a look. Just plop a couple of those and bring it up to the top. Okay, yeah, that's definitely gripping the piston quite nicely, or the spool valve. Let's just switch out and try the even fatter 10mm inner diameter 3.5 thick. Guessing this is probably too much. Yep. Probably would also work manually, but does grip the spool valve very tightly and therefore might jam up. Might have too much friction for pneumatic positioning. As has been stated, I was always going to end up with extra O-rings. Here you can see the size difference between the first O-rings I incorrectly bought and the correct ones. It's not much, but it's enough to leak a lot of air. These new O-rings are also better trained than the last ones. They can fit themselves. Well, that looked nice for the time lapse, but I just realized I put the spool valve in around the wrong way because this should be on this side. For the O-rings which seal here, I first measured them at 1.4mm thick, and that's what these ones are. But then I measured the actual seat, and it's also 1.4mm. So to make sure there's a bit of a crush, I bought some new ones. These are 1.75mm thick. Right, let's test this. Now, I don't expect the whole thing to work yet because I've only changed the seals in this front control valve. But this front valve is the one that receives the pressure air all the time. If this one's now sealed, then it means I've definitely got the right size O-rings. Okay, now while everything else is still leaking, this isn't. So what happens if I open the tool changer valve with Linux CNC? The valve must be moving, obviously leaking like hell, but that's also an improvement. Cool. So I guess I can go ahead, disassemble the other modules and replace the seals in them as well. Now I've got this little in-between job. One of my workmates has this old axe head. I believe it was his grandmother's favourite axe. Don't ask what his grandmother was up to with it, but anyway, he wants to restore it, he's already done a bit of grinding and stuff on it, and he found that there's a crack down here. And so he asked me whether I'll be able to weld this up. So I guess what I first want to do is get in here somewhere and just grind out as much of the crack as I can, and then just refill it with some filler rod. I don't think it's that important, it's only a little tomahawk axe, but I'll give it a go. I really can't get in much with that. Let's try something a bit smaller. Maybe it's best just to open up the crack with a bit of hacksaw blade. That could work. Right, let's crank up the trusty arc captain. Just patch in the foot pedal. There we go. Whoa. Oh, whoops. I just realized I didn't turn the gas on. That was stupid. Right, to get into these other two valves, I need to take this one back off again. This is the seal which I 3D printed last week out of TPU. Now I said this was the main pressure seal for the whole lifting assembly, but of course it's not. There's a seal down under there, that's the main seal. This is more just a dust and grit seal to stop coolant, dirt, grit, swarf, whatever, getting down into this mechanism. After last week's video, a gentleman with the username Trilobite, who's already converted one of these, posted a comment with the actual part number of the seal, the original. It's a V1603. And based on the catalog link, I got the geometry. And you can see it's a little bit more sophisticated than the basic square profile I made. See the curved inner surface, so it only touches in 2 points. With that, I could fire up Onshape, do a quick model, then export it to my Bamboo Labs H2S, and print it in TPU again. So this is how the new seal came out. I'm pretty darn happy with it. Really got quite nice sort of surface finish on that. Put that in and see how it works. It's interesting that this is the correct shape of that seal. It's kind of square with that lip sticking out the top. But the seal that came out of my one was this sort of probably crushed down round seal. So I guess it has been replaced at some stage in the past. Let's see if my version of a V1603 actually fits. Oh yeah. Well, it looks promising. So when I put that together, I used that tape to try and keep the wires from crossing each other, and it looks like that worked, because obviously there's the existing damage from when it was first done, but I don't seem to have made it any worse. However, the O-ring that was supposed to be here wasn't in properly. I saw that fall out, and you can see all the crush wounds on it, so be a bit more careful installing the replacement when it goes back together. You know, while we're at this point, I've just realized I've never actually seen this thing move in any way or form. So what happens if I take a gun and try blowing in these ports? Let me just see how much air pressure I've got on my compressor. Maybe I need a bit more air pressure, but that looks good. Wonder why that's only going up a little bit and stopping. Okay, so it is high enough to turn. Cool. There must be a position where it goes down and locks down onto the pins, so... I need to find that position again, because otherwise I can't time the thing, can I? Aha, that's definitely down and locked. Looks to me like that's a tooth out. I think this needs to be rotated one tooth. This is out of sync. Oh, wait a minute. Once this is retracted, this can be turned, so I don't need to disassemble it. I just need to align my alignment marks here. Cool. So this is now down on it fixing studs. So it's clocked. this is lined up, that's clocked, and the turning piston is right at the end of its stroke, so I think that's correct. Cool. I went ahead off camera and just switched over the rest of the O-rings in these 3 valves. So now I've got one more to do. It's this one. I don't particularly want to unthread all of my wiring again, so let's just see if I can get this done with it still attached. These sometimes catch on the circlip groove. So I've put those back on. I didn't bother showing reassembling everything because you can look in the last video if you're interested. So let's hope my new seal goes on as nicely as the old one did. There we go. Right, I need to do a little job on my ultrasonic cleaner. Do not use this tank when the tank is not to fill the water. And I obviously misunderstood that of saying I'm allowed to use it when it is to fill the water. And because I used the tank with not to fill the water, either heating elements outburnt. So you can see the 4 ultrasonic excitation units. I guess you call them loudspeakers, huh? And then down here's the 2 existing heating elements. You can see they're just wired in parallel. They're connected to line in neutral. There's nothing special about them. They're just 230 volt resistive heaters. And all I need to do is just wire my new ones into them. Come on, you brute, get out of there. So the replacement heating elements I bought are these 2. They're a bit bigger than the old ones were. Well, they're probably just the same, I'm guessing. They've just been stuck into an aluminium housing, whereas these were stuck directly onto the base. I'm not sure if there's even much point taking these old ones off. What I'll do is just glue the new ones, like one here and one over here, and then just not bother with the old ones. Doesn't really hurt anything if they stay stuck in the bottom there. Right, leave that overnight to dry. 13 degree water. Let's set it for 50. Give it a while, see if it heats up. Well, that heater is working. It's not going to win any speed races, but at least it does the trick. I guess if I wanted 50 degrees, I'll probably have to turn it on a couple of hours in advance, but it's probably also helpful if you put hot fluid in and let it maintain the temperature. My pneumatic system was leaking really badly before, but I found out that a lot of it was just one of these plug-in connector which I hadn't pushed in quite home, so it was leaking. Another issue was one of the unused valve modules must have had internal leakage, and once I put blanking plugs into its ports, that cut it down a lot. And there's still definitely a bit of leakage happening. I can even feel it down around here somewhere. And I also still have a slight leak in here as well. There's definitely still a bit more work to do to reduce the leakage, but at this stage it's much quieter. But the system leakage is not too annoying, so I won't worry about it at the moment. Now, since this is completely pneumatically controlled and the wiring is only used to feed back the position back to the controller, this should now work. Let's see. Hey! All right. Well, I am super happy to get to this spot. Way cool. So now I just need to wire back up the hall sensors for position feedback and then integrate the control into Linux CNC, but making good progress. Before I can go ahead and do the wiring, having a new tool, I gotta look and see what it looks like with everything set up on it. Very nice. So the next thing I need to do is splice this hall sensor module back into its wires. Want a nice curve on the solder sleeve so that it fits down inside there. So I'll just hold the curve while it's cooling. I've set up a watch list here for the 4 pins which these 4 hall sensors are connected to. Got a magnet here. So, okay, working, cool. I'm just going to try and get all this wiring in without too much pressure. Make sure I don't catch one on the lip or anything. Doesn't really matter what orientation this is because I can assign any one of these 4 pins to any position in Linux CNC. Since the potting compound of these hall sensors is kind of cracking and crumbling, I'll be very careful and not crank this down too tight. There's no load on it other than the wiring. Now to activate the hall sensors is this magnet and the cap. Now this cap has no fixed alignment, so I guess what we do is just put it on and then we can just rotate it around until one of the positions is activated and latch it. So we can see that I've got one of the positions showing here. That's about where it starts indicating. If we rotate it around, that's where it stops indicating. So I guess we'll just lock it halfway between those 2 place positions. It's just held with 3 little grub screws. Actually thinking about it, while this is electrically irrelevant which sensor is assigned to which position, at the moment it's the second sensor that's activating, but this actually clocks in a specific location because there's only 3 bolt holes for 4 positions, and therefore this is position 1. So why don't I just rotate this cap around so that I can set the first sensor to number 1 rather than counting sort of 2, 3, 4, 1. Let's make things a little bit easier to set up. Okay, so that's sensor 1 there. So okay, that hall sensor is indicating fine. Let's do another one. Yep. Perfect. So that means I'm now ready to start the reassembly of the actual tool holder block. Now, you really can see the eye for detail that Schaublin has. For example, this is a hardened steel insert. There's one of them on each of the 4 locations. So that's where the height adjustment screw acts. So rather than causing wear on the cast iron, hardened steel. And for the shaft mounted components, you've got a hardened ball here for the anti-rotation feature to stop against. Now the next feature I just noticed is, I already knew there's these two diagonal holes through here, and these two are used with grub screws to adjust the tool holder to make it perfectly square to the chuck. So I knew that they had worm screws that run in them, but I actually found that there is, and you can't really see it I guess on the video, but there's actually a little bronze pad acting on the threads, and that bronze pad is actuated by another grub screw coming down from the top into each of these two holes to make sure that you've got the adjusting screw perfectly locked off. Now before I install anything, I'll just quickly deburr the base of it. Because there has been a bit of damage here in the past and here, but they're not proud. Now last thing before I start the reassembly, I just noticed when I was laying these out that a couple of these bolts have become magnetic. But luckily, my mate David gave me a demagnetizer. So let's give that a go. These two are definitely magnetic. I guess you do them one at a time maybe. Not actually sure what I'm supposed to be doing. Cool, that worked. Well, that worked like magic. I don't actually know how a demagnetizer works, so for today, for me, this is magic. And since I'm busy making a video and editing, I probably won't have time to Google it. If someone wants to share in the comments section, how does a demagnetizer work? Please, go ahead. So these are the adjusters to clamp the shaft-based tooling. And that's the left-hand thread on there. It's all nicely hardened and ground. These are the clamp blocks and cams to clamp the main tool holders. And then there's just a bunch of hardware to hold it all together. Right, now I just need to align this. Looks okay for me. Wait a minute, I'm supposed to be using these to bump it around and not bumping it with a drift. Right, just double check that from a different position. Oh, okay, that's way off. So I do need to undo the bolts and adjust that. Right, well I spent another half an hour playing around with this. It does tend to change alignment slightly when you torque down the bolts. Seems about as good as I can get it. I'm within a couple of tenths. Right, so the main alignment was done on position 1. I've turned it to position 4. Okay, that's not looking too bad. So that seems repeatable. Well, I'm very happy to have the mechanical, pneumatic and electrical part of this finished. I still need to do the firmware configuration, but there's a software component called Carousel Comp, which was written by Andy Pugh, which Trilobite used and is using as far as I can tell. However, my current setup is an old version of Linux CNC. It's version 2.8. And I believe the version of the carousel component that was available back then is buggy. I see in the thread where Trilobite set up his system that there were bugs in there. So I think I'm going to have to update my Linux CNC build to get the latest version of that component. So I'll need to do that before I finish doing the setup. But I'm out of time for this week, so I'll go and edit this video. I'm kind of hoping that the firmware setup is not too much work. I've already made the tool change at HAL file. It's just going to need a bit of editing once that software's been updated. I won't bother doing another full video on this. Hopefully the next time you see this tool changer, it'll be working. Thanks for watching.